Hey, the next pre-calc topic is polynomial functions, and we'll just jump right in. A definition is this. It's an nth degree polynomial with non-negative integer n. So each x raised to a number goes down, and each an has to be a real number. So these an through a0 are elements of the real number line. And then this is what's called an nth degree polynomial. We will look at some notes here that a polynomial is always continuous. So like if you note this one here where it has a sharp point or edge, that's not a polynomial. If it's discontinuous, meaning there's a break in it, that's not a polynomial. And any other, possibility is potentially a polynomial. So it could have lots of wiggles, or just a straight line. But it has to be continuous, and I say smooth, continuous, and continuous. Has to be smooth, meaning no breaks, and continuous means flows. Smooth also means no sharp points. The leading coefficient, an, that one, determines the left and right ends of the graph, along with the degree, n. So, for instance, if n is odd, so 1, 3, 5, etc., and the leading coefficient is positive, we know that as we get further and further to the right, it always goes up and goes to infinity. And if this coefficient, the leading coefficient, is positive, we go more and more left, and then it goes down. And then if it's opposite, if the leading coefficient is negative, we know that eventually this will just go down to infinity, and as we go left, it will go up to infinity. If it's even, then both sides do the same thing. So if it's positive, they both end up going up. So like in a quadratic function where it's x squared, so which the 2 is our degree, and it's even, and it goes like this, right? But if it's a fourth degree, then there could be some bumps in here, but eventually it goes up. And notice the dots here, because we don't really know what happens between here using the leading coefficient, but we do know the ends of it. So and if the leading coefficient is negative and the degree is even, then they both go down. And we don't know what happens in here, but we do know eventually it goes down and down. So next, let's look at what's called the zeros of the polynomial. And that's a fancy way of saying where it crosses the x-axis. And if we look at this, f of x equals 0. So if you think of a number line, when f of x is like y, so when y is 0, it's here. So all the values along the x-axis that make it 0. There could be multiple points. Those are called zeros of the polynomial. And it's all values of x that make this true. So there could be more than one. So a few notes. The nth degree polynomial has at most n real solutions. So meaning it crosses the x-axis at most n times. And it has at most n minus 1 relative min or max, so relative extrema. And another way to say that is humps. So if your graph goes up and then down, then there's two humps, which means there's two relative extrema. And so a fifth degree polynomial has at most, it crosses the x-axis at most 5 times, and it has most 5 zeros, and it has at most 4 relative extrema, or 4 humps. Now this one here, the IFF, you may think it's a mistake, but in mathematics it's called an if and only if. So if A is a 0, if and only if x minus A is a factor. And the if and only if means it goes both ways. So if x minus A is a factor of our function, then it's also a 0. So it's an if and only if. And then let's briefly talk about repeated zeros. So if we can factor f of x into something like this that has a number here, then, well, x equal A is a 0 based upon what we just said here, but it has a multiplicity of k. And we'll do examples of each of these in a second. And so we know if k is odd, that the function crosses at x equal A. And if k is even, then it touches it but does not cross. And we'll give an example of this. And we will use the zeros of a function to graph the function. So let's jump right into examples here. So here we have a generic quadratic equation. So it's a second degree polynomial, which without even starting, it tells us that it crosses the x-axis at most 2 times, meaning there's at most 2 zeros. There's only one hump or one relative extrema. And so let's do that. So at most 2 zeros and at most 1 relative extreme. And we know that this is true because that's a quadratic. It's U-shaped up or U-shaped down. So it can only cross at most 2 times. And it only has one hump. So it has one, it's either a relative max or a relative min. So here are some examples. So if this is a quadratic, it has 0 zeros. It doesn't cross the x-axis. It has one maximum, and the leading coefficient is negative. And if you go back, it means that it falls down this way. This one, there's 2 zeros, has one relative extrema, and it's a minimum in this case, and we know that the leading coefficient is positive. In this case, it's a, boy, that doesn't look symmetric, does it? So this is a quadratic that only touches the x-axis once. So it has 1 0, and it has one minimum, and the leading coefficient is positive. And this one, it would be a multiplicity of 2 at that value. And I think I have an example to illustrate that. So if this one is, so this is a 5th degree polynomial. So it has at most 5 zeros, meaning it at most crosses the x-axis 5 times. And it has at most 4 relative extremes. So now let's look at some examples. So here's an example that has 1, 2, 3, 4, 5 zeros, has 4 relative extreme, 1, 2, 3, 4, and the leading coefficient is positive in this case, and remember the leading coefficient only tells us what happens at the extremes. Okay, so this one is another example of a 5th degree polynomial. Here it has 1, 2, 3 zeros, and again it has 4 relative extremes, and the leading coefficient is negative, so it tells us that the ends of the graph does this. This one here, a little bit tricky, but we could have a 5th degree polynomial that looks like this. And it's probably end up going to probably be a little flatter and etc. But this is close enough. It has 1 0, and it technically has one extreme, which is here. It actually is flat right there and then goes up again. Here the leading coefficient is positive. which tells us what happens at the ends of the graph. So let's look at this one. So f of x is this polynomial, which can be factored into this, which tells us the zeros are at -2 and -4. -2, -4. Leading coefficient is positive, so we know that it goes up. Next example, let's find a polynomial with zeros at -2 and -4. Remember, but the way you build that is this. You say x plus 2, x plus 4, then you FOIL that or multiply it and you get this. And this is exactly what we know because that's what we did here. But my point is that you can work backwards. If you know the zeros, you can create a polynomial. So let's do a little more advanced one. Let's say we want a polynomial with zeros, 0, -3, and 4. So then we do this. We create, this is a 0, so x plus 3, x minus 3. Now we have to multiply this thing out, which can be difficult at times. So what we do, let's just multiply these two pieces first and leave the x outside. So when you multiply those two out, you get this, and then we still have our x. So now let's multiply the x in. We get x cubed minus x squared minus 12x. So this is a polynomial that has these zeros. And if we were to graph it, it looks something like this. The leading coefficient is positive. Yep. So that tells us what happens at the tails. So let's find a polynomial that has zeros at 2 with a multiplicity of 2 and -3. So you create that this way. Or you could initially go x minus 2 squared times x plus 3, but I wrote it like this. Now let's multiply these two together, which you get this, and then we still have the x plus 3. And now we multiply this into this. And so here, so x3 is x squared times x, and then you take this times that, and then you go to the next term. This times that, and then this times that, then you go to the next term. This times that, that times that. Boom. So then you combine like terms and you get this. So here is our, remember we had these zeros. So this is a multiplicity of 2. So we have 2 at -3 and 2. And this is a repeated, that should be repeated, 0 with multiplicity 2. Now if we go back to our to this page, if it's a repeated 0 and k is even, it touches it but does not cross. So we know that the graph touches it here but doesn't cross. And when we plot it, it does look like this. And notice that, okay, there's 2 zeros. There are 2 relative extremas right here and here. And the leading coefficient is positive, so which tells us what happens at the extremes. And we'll do one more. Okay, ignore this graph initially. So here's a graph. Here's a function. We know it's a 5th degree polynomial. When we multiply this out, we're going to get an x squared. And when we multiply this out, we're going to get one of those as an x cubed. But then we multiply those together, we get an x to the 5th. So it's a 5th degree polynomial. Now, because it's a 5th degree polynomial, and if we were to multiply it out, these coefficients in front are positive, so whenever you multiply those, it's going to be a positive back. and that tells us that it falls to the left and rises to the right. Now notice that the zeros are at -1 and 3. Now these have a multiplicity, so this 0 has a multiplicity 2 and this 0 has a multiplicity 3. So if we look back at this, the multiplicity 3 is odd, so it crosses it at that 0. And the even multiplicity says it touches it but does not cross. So at this 0 it touches it but doesn't cross, and at this 0 it crosses it. Okay, but we don't, to get a better, well, let me rephrase that. Because we know it's a 5th degree, the positive first coefficient will be positive. The tail does this and that, but we don't know what happens in here. So let's pick a value in here so we can get a number and then give us a better idea of what the graph looks like. So let's test a value between these. And to me, picking 0 is easy, because then, you know, plugging in 0 to this equation, it makes it easy. So f of 0, we end up getting -18.5. So we know it crosses at that 0, and we just plug that value in, so we know it touches that point and goes to there. So it does that. Okay. Well, that's all I have for today on polynomials. I hope you enjoyed it. If you did, please like it, and also subscribe so you don't miss the next video. Thanks. Bye.